But it's going to be the absolute value of A. Remember, the vertical stretch or shrink factor is a positive number. Like if it's like 3, it's vertical stretch by 3. If it's 1/2, vertical shrink by 1/2. If there's a negative, it just means there's a reflection, right? So it's separate. So what this does, I'm just giving you an overview first, and then we're going to look at a bunch of examples. What this does is instead of going between 1 and -1, what happens if you get amplified in the vertical direction? It's going to be like, let's say vertical stretch, let's say the amplitude is 3, it's going to go between 3 and -3. Do you guys see that? That's all that is. Okay, how about the vertical shift? What is that going to be? Either up or down, K, right? Up or down K in the same direction as the sine. So remember, the period is the length of one cycle. Length of one cycle. So normally in the parent function, how much was one cycle? It was from 0 to, do you guys remember? 2 pi, right? Like one full rotation is 0 to 2 pi. So normally it's 2 pi, right? Normally it's 2 pi. But remember, the horizontal stretch or shrink is going to affect, right, how long it's going to be in the horizontal direction. So if I multiply by the horizontal stretch or shrink factor, right, that's the horizontal stretch or shrink factor, it's going to like give you the size now of one cycle. So the way that we write this, though, you're going to see it as like 2 pi over b. 2 pi over b. And again, it's the absolute value of b because we're talking about like the length, right? So it's going to be positive. And then if it's negative b, the negative would just be a reflection. So 2 pi over b tells you the period or the length of one cycle. We can like stretch it out or shorten it. Yes? You guys see that? So like let me just talk to you about the sound example. Let's say I have like a regular graph. What happens if I amplify the sound? What happens in real life? If you have an amplifier, what does it do? Like it makes it louder, right? So you can amplify the sound, right? What happens if so that's like stretching it vertically. How would these differ? So let's say I have one with a short period, right? Like, let's say from like here to here, that's one cycle, right, before it repeats itself, versus like one with a longer period. How would they sound differently if you were to compare them? The one with a short period has a higher frequency, so it's going to have a higher pitch, yeah, like a higher tone. And then the one with a longer period, right? Yes, it's going to have a lower frequency, so it's going to have a lower sound, lower pitch, yeah? Okay, so let's take a look at a bunch of examples. Any questions before we get started? Yeah? All right, so here's the first example. Y equals -3 sine of x. We're going to have to graph this. So do I have any like horizontal stretch or shrink or anything like that? There's no change, right? Just a reflection and a vertical stretch by 3, right? So what I do is, what is my amplitude, by the way? 3. It's not -3, it's 3, right? It's been stretched by 3, so it's been amplified by 3, and there's a reflection there. And then what is the period? 2 pi, right? Because there's been no change from the parent function. So what we can do is we go from 0, and this is how I do it. I make a tick mark at the end, one in the middle, and then cut those in halves. That way I have spots for the 5 key points and like 4 intervals total. And then I'm going to label it. I'm going from 0 to 2 pi. Halfway is pi, right? Half of that is pi over 2. And then 3 pi over 2 here. Remember, it's just the quadrant angles going one full circle in the positive rotation. So in the y direction, though, what numbers are we going to put? Not 1 and -1. We're going to put 3 and -3, right? Because the maximum and the minimums, it's been stretched out to 3 and -3. This is a sine graph. You sine at the line, right? So you sine at the line. So I'm going to have the intercepts here. Sine at the line, meaning you're going to start at the x-axis there. And then it's a negative sine graph. So instead of going up to the max, we're going to go to the minimum first, down to the minimum, and then to the maximum. Okay, so make sure like these points, they're like lined up, right, at the right intersection when you're graphing these. Yeah. There we go. So there is one period that I've graphed based on the function that was given to me. Okay. Guys ready for the next one? Yeah? Okay. Let's take a look at the next example. We have y equals sine of x over 2. Okay. What number is in front of x? Like, what's the coefficient of x? It's not 2. It's, what is it? I think somebody said it. 1/2. Do you see that? Do you see how this is like 1x over 2? So it's like 1/2 is the number in front of x, or the coefficient of x. So that's going to be your b value. Okay, that's going to be your b value. So what is the period going to be? Remember, normally it's 2 pi, but I'm going to divide by the b value. What's the b value in this case? 1/2. So 2 pi divided by 1/2 is the same thing as 2 pi multiplied by 2, which gives me 4 pi. Right? So it's been stretched. Right? It's been stretched. It's going to be, instead of 2 pi long, it's going to be 4 pi. And that's the only change we see here, right? So I meant 0. Again, I make all the tick marks here, 4 intervals. I'm going from 0 to 4 pi. How long is each interval or each increment? Pi, right? It's going to be 0, then pi, 2 pi, then 3 pi. Right? So in our head, we're thinking, right, the increment is going to be whatever your period is, and then we're going to divide it into 4 even pieces, right? So 4 pi over 4 gives us pi. Are you guys okay with that? This is like pi units long. This is pi units long, yeah, and so forth for a total of 4 pi. Olivia, you look like you have a question. Which part? The period. So the way you find the period is 2 pi over b. And so for the other one, it was 2 pi because I didn't have a change, like I didn't have a horizontal stretch or shrink factor. The b was just 1, right? So you want to go back and look at, you know, the general sense of things, right? The period is 2 pi over b. Okay? So I know the whole thing is 4 pi. I have to divvy it up into 4 even intervals, so you just divide the period by 4. Okay, so you're here, the increment is the period divided by 4, right? Because I need to add, you know, I need to like add by the same amount each time, right? Okay, so in the y direction, what is it going to be here? Just 1 and -1, right? Because there's an invisible 1 right here. Yeah. It's a positive sine graph. Where do I start? You sine at the line. So we start here. Yes, and you have a positive first, and then a negative, max, and then a minimum. And then you connect the points together in a nice, smooth curve to get our graph here. Okay. Do you see how this is like horizontally stretched? Because normally your graph would be like that, yeah? But it's been doubled. Yes?
So when we're placing, like how you said, sine on the line, and then we put the 3 points on the line.
Yes.
Is it always those 3 points that you put on the line?
Yes.
Okay.
So think about it. Anytime you go between max and min, you have to go through the intersect, right? So it's going to be, yep, the first, third, and the fifth points are going to be on the line, on the axis.
Thank you.
Okay, questions. Please ask me questions. You guys are okay? Because like I'm adding like one thing at a time, right? We're going to do one with a shift. Here we go. It's an example. So we have y equals 1/2. So example, you have y equals 2 plus 3 sine of 2x. Okay. So this tends to throw students off a little bit. So can we rewrite this so that it's in the order that we usually see it in? How could I rewrite this? So 3 sine of 2x plus 2. Okay. And if you want, you could put the parentheses around the 2x so that you can visually see that that's the only thing on the inside. So in this case, we don't have a phase shift, but we have a, what kind of shift?
Up and down.
Up and down shifts. Vertical shift, right? Vertical shift, yes. Okay. So go ahead and fill this out for me. Amplitude, period, increment, phase shift, and vertical shift. Okay, go ahead and fill this out for me, and then we'll go over it together. So amplitude is 3. Period is 2 pi over b, where the b in this case is 2, right? So pi is going to be your period. You guys okay with this? Yes.
How is the b 2?
So b is the coefficient of x. So the number in front of x is the b value, right? And then the number in front of the sine, right? That's your a. Yes, tells you the amplitude. Yes, okay. So your increment's going to be pi over 4, right? Because it's the period divided by 4. Phase shift, it's none because you're not adding or subtracting by a number on the inside of the parentheses. Vertical shift, you're going up 2, right? It's plus 2 here, so it's going to be going up 2. Okay. So let's go ahead and get this started here. I'm starting at 0 since I don't have any phase shifts, no horizontal shifts. How much am I adding by each time? Pi over 4. So 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4 or pi over 2. And then if I add another pi over 4, it's 3 pi over 4, and then it's 4 pi over 4 or pi. You're adding by, remember the total value right here? What's the total length? Pi, right? 0 to pi, that was a period, yes? So each little increment is pi fourths. Are you guys okay with this? We're just labeling it. So in the y direction, what do I write down here? 3 and, oh, yes, thank you. Ooh, yes. So we have the up to, so we got to start, we're clicking and dragging and starting at up to here. So that's going to be like my new x-axis. That's going to be like my new line. So you know how we normally start at 0, 0? We're going to start at 0, 2 as my origin. And then from there, I'm going up 3 and down 3. So if I go up 3, how much is that? 1, 2, 3, 5. And then if I go down 3, how much is that? -1. Yes. So these are the points that I'm going to be looking for: 5, 2, and -1. Right? Because y equals 2 is where your x-axis is going to be, or your midline of your graph, right? And then the 5 is the max, and then the -1 is the min. Do you guys see that? Just everything's been shifted up to. This is a positive sine graph, so where do I start?
0.
Right at the line, like you sign at the line, and meaning like the x-axis. Yeah?
Yep.
You guys okay with this? And then every other one, right, is going to be at the x-axis. And it's positive sine graph, so we're going to go to the maximum and then to the minimum. So max, minimum. And your graph should be like nice and symmetrical. And then you put the arrows at the end, like so. Questions? Yes, Gigi.
I and C.
The increment?
Yeah, how do you find that?
So the increment right here is, the increment is the period divided into 4 even intervals.
Oh.
So that way you know, like, this is pi over 4, right? This is pi over 4. This is pi over 4, right? Because it's pi divided into 4 even pieces.
Okay.
And that's why we added pi over 4 each time. Yeah? Other questions? So you're going to have to practice this, right? It's just all the pieces are there in your head. It's just getting really good at it by practicing. Okay.